preview. There we go. We should be all set now. All right, so good morning, or good afternoon. I keep saying good morning. All the other classes are in the morning. This is the only afternoon one that I have. Good afternoon. Today is A4 Pre-Calculus CP. It is Monday, April 6th. Hopefully you're all having a fantastic day, and hopefully you had a fantastic weekend. Today, what I'd like to do is I'd like to teach you about the area of irregular quadrilaterals, which is really just an application of all of the skills we've already learned in this class so far. So it's not really learning anything new. It's really just learning how to tackle a new type of problem. Couple of reminders I want to give you before we get started officially is number one, if you haven't done so already, please make sure you fill out the attendance form on Google Classroom. It's there. It's the same form every time. Just make sure you click that you are present today. Number two, you may want to have the law of cosines homework document open in a separate tab because I would like to go over problem number 5 on that document with you. Just because we haven't gone over a word problem together, even though a couple of them have shown up on the homework. Hopefully you were able to handle them. So I do want to talk about one of them with you just to, for the sake of going over a word problem and getting a little extra practice on the law of cosines. And then, let's see, the other thing I want to remind you of is progress assessment. So at the end of class today, it's actually scheduled to arrive in your inbox at exactly 1:30 p.m. You will receive the progress assessment for pre-calc. It is due to me by the start of our following class. So the next time we see each other is April 8th. So please make sure you have it submitted to me by the start of next class so that I can grade it, provide some feedback, and make sure that we can clear up any misconceptions prior to the summative assessment. Speaking of which, we did agree that the summative assessment is going to be on April 14th. That's just about a week from today. We do have a review day on April 8th before then, so that'll be your opportunity to ask any questions that you have on area, law of sines, and law of cosines. But that day will be entirely summative day. The way it's going to work again is I'm going to post that summative assessment in the morning via email again, same deal as I just did. You are going to have the entire day to get it done. Our half-hour session together will be more of you popping in to ask any questions or any clarifying questions if you have clarifying questions on the actual summative assessment. I won't be doing any quote-unquote teaching or new teaching on that day, so it's just an opportunity for you to come in and ask questions. But I will ask, and I'll remind you as we get closer, that you do come in and fill out the attendance form just for attendance purposes, because it is important for me to track attendance data to make sure you're all still tuning in and keeping up with your work, as I know you are, because you're a fantastic pre-calculus group. So let's go ahead and get started, shall we? Like I said, I'd like to start by going over problem number 5 on the homework. I think it's a great word problem about the law of cosines. All right, and it has a great real-life connection too. So, problem number 5 says the following. It says, a satellite dish can track the speed of a plane by recording the distance to the plane at 2 points in time and the angle at which the dish rotates. In the picture below, a satellite measured the distance to a jet at 35 miles. After 0.25 hours, or 15 minutes, it measured the distance to the jet at 58 miles. And it said if the satellite rotated through an angle of 132 degrees, what would the velocity of the plane be? And remember, from physics, the velocity is distance over time. That's something that I'm sure have seen in Physics First or a similar class. So what's really going on here is we have this triangle. I have the satellite down at the bottom. It's measuring the distance that this plane is traveling. So we have our plane up here, call it P1. And it travels over to this point over here. Not going to try to draw like I did on the answer key. That was kind of a disaster. There's P sub 2. And I have my satellite dish here. It measured a distance of 35 miles initially. It then measured a distance of 58 miles. Clearly this is not drawn to scale. And our angle that the satellite dish rotated is 132 degrees. And so the question is asking us to find the average velocity of the plane. Now, in order to find the velocity, hopefully you recognize that I need to find the distance because velocity is equal to distance divided by time. So I need to find this distance right here. How far did the plane actually travel in that amount of time? In order to do that, we can go ahead and use our handy-dandy law of cosines because we're given two sides and included angle. Notice that there really isn't anywhere to go with the law of sines because we don't have anything that's across from each other like we've seen in all our law of sines problems. Here we have to use our law of cosines, but that's okay, we can do it. So I'm going to say that if I call this side c, we can say c squared is equal to a squared plus b squared minus 2 AB cosine of C. Because that's our law of cosines that we're all familiar with, yes? Going from there, I can say, well, C squared should equal, let's just fill in our information. Let's call this side A and call this side B. It doesn't particularly matter which one you call which, as long as that included angle 132 is right in the middle. So I'm going to say we have 35 squared plus 58 squared minus 2 times 35 times 58 times the cosine of 132. Okay? Does everybody see how we're just filling in our law of cosines formula? And again, this is to find this distance right here, which we will then use to find the velocity. So that means that C squared is equal to, let's see, we're going to use our handy dandy calculator. We got 35 squared, so we got 1,225, plus 58 squared, 3,364, minus, we got 2 times 35 times 58, so minus 4,060 cosine of 132. A little bigger numbers than we're used to, but that typically happens in a real life application where we're going to be dealing with real data. It's not just going to be like the distance is 5, you know. So I now have C squared is equal to, just using a calculator to add all those together, we got 1,225 plus 3,364 minus 4060 cosine of 132. And again, ensuring that your calculator is in degree mode, we get that this is approximately equal to 7,305.67. I take the square root of both sides, and we'll get that C is equal to, let's do the square root of 7,305.67. We get approximately 85.47. Okay? So what that means is that this plane traveled approximately 85.47 miles from the first point it was measured to the second point it was measured. You can now go ahead and find the velocity because, again, remember, and it's in the problem from physics first, your velocity is equal to the distance divided by the time, distance traveled divided by time. It gives us that the time was 15 minutes or 0.25 hours. The distance we just found is 85.47 miles. And so just dividing the two, we can go ahead and find the velocity by doing 85.47 divided by 0.25, and I get that altogether this jet is traveling 341.88 approximately miles per hour. Okay. Does that make sense to everybody how that was done? And does anybody have a question on that problem? Hopefully we're doing okay. Hopefully it makes sense. Logical, I hope. Okay, fantastic. All right. Now, what I'm going to do is, again, I want to show you how to find the area of irregular quadrilaterals. And the area of irregular quadrilaterals will really just be a recap of the other skills that we've been using, just now applying them to solve a different problem. So it's not really a new skill. It's more or less just a new problem that we can face with our pre-existing skill set. Okay? So does anybody have a question on this before we move on? All right, I take your silence as we're A-okay and all good to go. Okay, so let's talk about some irregular quadrilaterals. Hey, what do you know? There's an irregular quadrilateral right there. How convenient. So, first things first. There is no magic formula that's required to find the area of quadrilaterals. I can't just say, look at this irregular quadrilateral, and by the way, irregular meaning the fact that it's not a square, all the sides and angles are not the same, it's really just a random four-sided figure, right? There's no magic formula that can help us find the area of that. However, we do have a handy-dandy triangle area formula, and that handy-dandy triangle area formula is that the area of a triangle is 1/2 AB sine of C, right? You know that from geometry. You also know that from what we just talked about, where a couple classes ago, where we said that the area was 1/2 AB sine C. Just dropped my pen. Okay, so that's helpful, but now how can we apply that to this? Well, what we can actually do with any of these quadrilaterals is we can split them up into two triangles and then pretty much find the area of both independently and add them together. So that's really going to be our strategy going forward, is to split this quadrilateral into two triangles, find the area of each triangle independently, and then add those areas together to get my total area of the quadrilateral. All right, and it'll be a nice review of that formula of 1/2 AB sine C, where you have two sides in the included angle to find the area. A couple things I want to mention before we get started. Number one, these quadrilateral problems can be very tricky if you are not given a right angle. If you do not have a right angle as one of the angles of your quadrilateral, you can run into a lot of cases with ambiguity, and where it may be acute or obtuse and you don't really know, and you have to do a lot of different checks. For our purposes in pre-calculus CP, we are not going to do any quadrilateral problems that do not have a right angle. So all of our quadrilaterals will have right angles, so we don't have to worry about any of those checks for ambiguity. The second thing I want to mention is that when you split your quadrilateral into two triangles, because that's what I'd like to do. I'd like to create two triangles here so I can just find the area of both of them. It makes a lot of sense to keep that right triangle together, right? Think of if I'm going to draw a line to split this into triangles. I wouldn't want to draw this line because that would cut into my 90-degree angle. The 90-degree angle is a luxury. I want to make use of that by cutting our quadrilateral like this. And so I now have a right triangle right here by connecting these two angles, and I have this other random triangle over here. Does everybody see how that was done? So the nice thing about this is I could actually go ahead and find the area of this first triangle right away. Since it's a right triangle, we're given the height and we're given the base. So you can go ahead and say that the area of that first triangle is equal to 1/2 base times height, right? Just straight from geometry. Notice how that's actually the same formula as this, 1/2 AB sine C. It just so happens that our 90-degree angle, the sine of 90, is 1. And so really it's 1/2 base times height, which is the formula you've been doing all along since geometry. So what you're telling me now is that this is the same exact formula that you've been using all along. It just so happens that now we can approach angles that are not 90 degrees. Amazing. Unbelievable. And yes, that's absolutely the case. Where I could just go ahead and find the area of this first one if I wanted to. The second one, however, I can't yet. And I can't yet because what I need, again, in order to apply this formula, is I need two sides and an included angle. I have one side, this 7.2, but I need to get this side right here. I don't know what that is. I need to get the measurement for that side. And I need to also get this angle. That way I have my side, included angle, and other side, right? Without that, we just can't really make any headway with that area formula. Luckily for us, though, we can use this right triangle to very quickly find the measurement of this side. Notice if this is not a right angle, we have to refer to our law of cosines, but since it is a right angle, we could just do a little Pythagorean theorem to find the length of this dotted line here. So I can say that first, to find the missing side, I could do just Pythagorean theorem. C squared is equal to 5.8 squared plus 3.6 squared. Okay? Which means that C squared will be equal to, again, handy dandy calculator, we got 5.8 squared plus 3.6 squared. So we get about 46.6. And then take the square root of that, and we get that C is approximately 6.83, we'll call it. Okay, so that means that this distance right here is about 6.83, which is good. I now am looking just for this angle. I have the two sides that I need. I need that angle, though, in order to apply my area formula of 1/2 AB sine C. I need two sides and the included angle. Now, luckily, we know the measurement of this entire angle. The measurement of this entire angle is 76 degrees. So what I can do is, if I can find the measurement of just this piece, I could say, well, then this angle over here should be 76 minus this piece. And if I do 76 minus this piece, that will tell me what that angle is right there. Well, now that presents a new question of how do I actually get this angle? Well, we can get this angle by just referring to our right triangle trig. Because this is a right triangle, we could say, well, let's use sine, cosine, or tangent in order to figure out the angle that's here, the missing angle, right? What I would elect to do is I would elect to say that the tangent of theta, this little piece right here, remember tangent is defined as opposite over adjacent, so I would say that the tangent of theta would be equal to 3.6 over 5.8. Okay? The reason, by the way, that I'm electing to use tangent, certainly you could use cosine, which is adjacent over hypotenuse, or you could use sine, which is opposite over hypotenuse. But I'm electing to use tangent because these two values were given to us directly, and they weren't approximated. This value we found by approximating, so therefore it may not give us the most accurate result. I'll actually show you in a little bit, because we had to round, right? These values were exactly the values that were given to us, so it makes a lot of sense to stick with those exact values. So I'm saying that the tangent of theta is opposite over adjacent. It's 3.6 over 5.8, a little SOHCAHTOA. I can now apply the tangent inverse on both sides to actually get what that angle is. And I can say that that angle is equal to the tangent inverse of 3.6 divided by 5.8, which comes out to be about 31.83 degrees. So I'd say that theta is about 31.83 degrees. That means that this little portion right here is exactly that. That little portion is about 31.83 degrees. And if I know that the entire angle is 76, but this little section of the angle is 31.83, well, we can just go ahead and find the other section by doing 76 minus our 31.83, because that means that this other piece should be 44.17 degrees to make up the entire 76. Does that make sense how we found that? So this was finding the missing angle, by the way. Okay. Find the missing side. So now I have all the information I need. I have side, angle, side here, where I can go ahead and use my area formula for the first triangle. I have now side, angle, side here, where I can use my area formula for the second triangle, right? If I call this first triangle T sub 1 and this second triangle T sub 2, let's do the areas now. The area of T sub 1, I could now say is equal to, using my area formula, 1/2 times 5.8 times 3.6 times the sine of 90 degrees. Note that again, the sine of 90 degrees is just 1, so it's really 1/2 base times height. So it comes out to be, let's see, using a calculator, we got 0.5 times 5.8 times 3.6. And we get it comes out to about 10.44 square units. The area of triangle 2 we could find much in the same way. This is not a right triangle, but we can still use the same formula to now say it's 1/2 times one side, 6.83, times the other side, 7.2, times the sine of the included angle, sine of 44.17 degrees. So that tells me now that the area of the second triangle is going to be equal to 0.5 times 6.83 times 7.2 times the sine of 44.17. Again, one more note is you want to make sure that your calculator is in degree mode for all of this. You don't want that to be your little mistake that messes you up along the way. And you get that the area is about 17.13 square units. And so therefore, if you know the area of the first triangle is 10.44 and the area of the second triangle is 17.13, we could just go ahead and add them together to say that the total area now should be 10.44 plus 17.13, which is mental math that I should be able to do in my head to get that the total area is 27.57 square units. Okay. Does that make sense how that was done? Hopefully. Yes? Just a little recap as you're processing how that was done. I split my quadrilateral into two triangles, one right triangle and one just random scalene triangle. I was able to find this missing side right here by using a little Pythagorean theorem with the right triangle. I was able to find this missing angle by first finding this angle with using tangent and then just subtracting it from the total measurement. Once I had that information, I could now use my triangle area formula on the first one and my triangle area formula on the second one, and then just add them together. Are we happy with that? I'll show you one more example of that before we end class here. But we're all feeling good? Making sense? Sinking in? Good, good, good. Excellent. Okay, let's see. Where can we find another irregular quadrilateral? Ooh, there's one. Nice irregular quadrilateral right there. Yes, as good as any that we can go ahead and find the area of it. That's what the directions will say, by the way, of any problem like this. It should say find the area of the following quadrilateral. Again, the general strategy is to split this quadrilateral up into two triangles and then find the area of each triangle. Once again, we would like to preserve this right triangle. I don't want to cut the right angle because that like gets rid of the most useful piece of information that we have a right triangle. Let's keep that right triangle in there by splitting our triangle like this. Okay, just like that. Do you see that? Now I have one triangle here, this big right triangle, and I have another random triangle over here. Okay? Just like before, I need to find this side. I don't know what that is. I'd love to find it. And I need to find this angle so that I can go ahead and find the area of this triangle by using the 1/2 AB sine C, because I need my side, angle, side, right? This first triangle is all set and ready to go right now. But let's do a little bit of work in order to find out some information for that second triangle. First, to find the missing side, just like before, I'm just going to use a little bit of Pythagorean theorem. Note that if it were not a right triangle, I'd have to use a law of cosines, which makes it a little more complicated. But since it's a right triangle, we just say c squared equals a squared plus b squared. Because if you notice the rest of the law of cosines, minus 2ab cosine c, since this is 90, cosine of 90 is just 0, so that just eliminates that whole term right there. That's why the Pythagorean theorem is a more specific case of the law of cosines. So just like with triangle area, where you've really been doing the 1/2 AB sine C all along, you've also really been doing the law of cosines all along. It's crazy. So it's almost like math is all connected. I get c squared is equal to 4.2 squared plus 4.5 squared. We're going to say c squared is, using a calculator, 4.2 squared plus 4.5 squared, and we get about 37.89. We're going to take the square root of both sides and get that c is approximately equal to, we'll call that about 6.16. Okay? So that's be our measurement for this hypotenuse right here, about 6.16. And one more point about your answers, by the way. As you're doing your work, your answers should make sense. I would look at that and say that is a reasonable answer because remember, the hypotenuse of a right triangle should be the longest side, right? Or its legs should be shorter. And the getting the result of like 6.16, you'd be like, yeah, that seems logical. That seems like it makes a lot of sense. Even in the previous example here, struggling to get the paper to flip over here. Here we go. Even in the previous example, notice again that my hypotenuse is the longest side. And it seems reasonable that if this leg is 5.8 and this leg is 3.6, then an answer of about 6.83 should make a lot of sense. You should not get a hypotenuse that's shorter than either of your legs. And you also shouldn't get one that's like 50. It wouldn't make sense to say, oh, this is 4.2, this is 4.5, that's 50. Like, that doesn't make any sense. So use a little bit of common sense as you're working through your problem to make sure that you're doing things correctly. Likewise, now we're going to go ahead and solve for this angle. That angle should certainly be less than 90 degrees right here, this little missing portion, because this is 90 degrees, right? And you might notice that both of your legs are of similar lengths, so it should make sense that your angle should be about 45 degrees. Definitely not exactly 45 because then the two legs would be the same, but it should be somewhere in that vicinity. Like if you got an angle measure here of like 89 degrees, like that probably, does it really make sense that this is 1 degree? That probably doesn't make any sense. So just double check as you're working through your problems to help make sure you get accurate results. Okay, anyway, back to this. So now I'd like to find this angle measure here. I don't know what that angle measure is, but I can certainly find this angle measure and then subtract it from my 127. In order to do that, I'm again going to refer to tangent. I'm going to say that the tangent of theta. This is now to find the missing angle. I can say that my tangent of theta should equal opposite 4.5 over adjacent 4.2. We can go ahead and apply the tangent inverse on both sides to eliminate that tangent. Tangent inverse of the tangent of theta should equal the tangent inverse of 4.5 divided by 4.2. And that gives me an answer of theta is, going to our calculator here, the tangent inverse of 4.5 divided by 4.2. And we get about 46.97 degrees. Right? Didn't we say it was pretty close to 45? That's not bad. Not bad. Okay, good. So what that helps me get is that helps me get the actual measurement of this. What I'm actually interested in is saying, well, that unknown measurement now would be our total of 127 minus our piece of 46.97. And we get that this is about 80.03 degrees. Okay. Now I have all the information that I need. Now I have my side, my included angle, and my side for this triangle. I have my side, my included angle, and my side for this triangle. We can go ahead and find the area. Again, I'll call this T sub 1. We'll call this T sub 2 for triangle 1 and triangle 2. The area of the first triangle should be equal to 1/2 times 4.2 times 4.5 times the sine of 90. Again, the sine of 90 is not necessary because the sine of 90 is just equal to 1. That way it's really just 1/2 base times height. By the way, you could, if you wanted to, use, I don't know why you would, but you could use this angle if you wanted to find the area by doing its 1/2 this times the sine of the included angle. That just seems like way unnecessarily harder, but you could do that if you really wanted to. But I would get that my area is, let's see, 0.5 times 4.2 times 4.5. I would get about 9.45 square units here. And if I find my area of the second triangle, the area of triangle 2, I would say, again, using this information over here, definitely a little more calculator intensive, 1/2 times my one side of 6.16 times my other side of 2.8 times my angle that I solved for, my included angle of the sine of 80.03 degrees. Okay? So when I put this all together, we're going to get, let's see, the area of the second triangle is, calculate 0.5 times 6.16 times 2.8 times the sine of 80.03. Ba-bam! We get about 8.49 units. And so now I can just go ahead and find the area of the whole quadrilateral. By adding these two together, I would say that my total area is your 9.45 plus your 8.49. And you would get some mental math that I can probably do, hopefully, about 17.94 square units. Okay. Does anyone have a question, comment, or concern about how that was done? Just to recap, as you're processing and thinking of those questions, what we did again is I just went ahead and split my irregular quadrilateral into two triangles, one right triangle and one just random triangle. In order to find the area of the random triangle, I needed to find this side, which we could do using Pythagorean theorem, and I need to find this angle, which I could do by finding this adjacent angle and subtracting it from this total measurement of 127. Okay? Once I did that, I now have my side angle side, which I can go ahead and use my triangle area formula of 1/2 AB sine C. Okay? Excuse me. Does anyone have a question about how that was done at all? We're feeling great. We're doing great. We've arrived at the end of our Monday's schedule of classes. Fantastic. We made it successfully. Great job. So just a couple reminders as we're wrapping up. Number one is that your progress assessment should be actually in your inbox as of 1 minute ago. Please make sure that's done by the start of next class. I think that's plenty of time to get that done. That way I can grade it and get feedback to you. Remember to just take a picture of your answers and send them to me. Next class, by the way, the 8th, will be a review class. So I'll do a problem on area, I'll do a problem on the law of sines, and I'll do another problem on the law of cosines just to make sure we're all up to speed. And then we'll probably have about 10 minutes after all of that, and so I can field any questions that you guys have. And the class after that will be our April 14th meeting. That is when we do have the summative assessment. So I'll share with you more details on that next class. I don't want to stress you out right now. But in any case, thank you so much for your attention and focus today. Remember to fill out the attendance sheet on Google Classroom if you haven't done so already. And I hope you have a fantastic rest of your day. All right. Thank you.